Good evening. Good afternoon, everyone. My name is Tokai University, and I am studying in Department of Biology, Microbiology, and training in Department of Civil Engineering, which is an internship program at Tokai University. Thank you all for attending my presentation today. Professor Kasumi Terada is my supervisor, and I also have a really good chance to help Mr. Musashi Kasumi in this project. The aim and objective of the project are to assess the current water quality in the bay affected by the Great East Japan earthquake, and to analyze the water quality of samples taken in Nagasura Bay. On 11th of May 2011, the Great East Japan earthquake was happened, as we well know. It was the most powerful earthquake ever happened in Japan. From this slide, this picture shows before and after the tsunami happened. As you can see from first picture, there are many residences around this area. Many people live and work there, and the most well-known career is oyster farm around here. It's very famous. But then, after the tsunami, you can see from this picture, the water came, many houses has been destroyed. But many people still would like to come back and live and work there. That's why we need to analyze the water quality in this area. In this picture, from N1 to N8, show the location of samples collected in Nagasura Bay, that we collect some samples to analyze the water quality. But because this situation has been happening for a long time, 2 years later, so the water sample has already been collected. So Mr. Kasumi, who is the master cross student in Terada lab, brought me to Kanamat River, which is nearby the university, to collect some water sample. And he also taught me how to do field observation and show me how to use the water analysis instrument, this one. This system can analyze DO, which is the dissolved oxygen, light, depth, and chlorophyll, and also turbidity, this one. And these are some samples that we collected from Kanamat River and Home Square. In this photo, you can see the white rebel is the one that we use filter before we collect the sample. And the yellow one didn't use anything. So you can see the difference of the water. The materials using in this analysis are test tube, water samples, pipette, and rubber glue, Hutch DR890, pure water, TP degradation solution, and phosphate reagent. So, the analysis starts with measuring 10 ml of the water sample into the test tube by pipette, like this one. Then next, we add some reagent into the test tube which is the phosphate reagent. Shake around 1 minute and wait for 5 minutes. Then we put the sample into hutch and press the read button. The result will show on this monitor, just only a few minutes. And then we record all the results. We have to run 3 times per one sample because of the error. These are some pictures while I am doing the analysis. And after we adding the reagent, just for a couple minutes, if you see the sample turn into blue or dark blue, like you can see on the picture number 1, it means that sample have high % of phosphate. But this one, compared with pure water, there are no color, so it means the % of phosphate is very low. In this project, I ran around 21 samples. And all the 21 samples results are now showing by this graph. And as you can see up here, the second graph shows total nitrogen that we found in our sample. The highest peak is around N7 over here. And the third photo, the third graph, it shows total phosphate. And you can see it's increasing. So we think maybe because that area have many of seaweed or mud there. And in this project, moreover doing the project, I also learned many new things which I didn't have chance if I am in Thailand. Especially doing studying about civil engineering. Most of all, I might thank you for my family, which always encourage and support me. And I also thank you, my professor, that opened for a biology student like me. And last but not least, thank you for the great opportunity from KMITL and Tokai University in this internship program. Thank you very much.